Now, if we look at what we have discussed till now, we have discussed the Matthew effect in science. Okay. Initially, we discussed Matthew effect in science in terms of reward and communication systems, and then we moved on to the Matthew effect in science in terms of cumulative advantage and in terms of intellectual property, symbolism of intellectual. Then we discussed what is cumulative advantage in science, which refers to the social processes through which various kinds of opportunities for scientific inquiry as well as the subsequent symbolic and material rewards for the results of that inquiry tend to accumulate for individual practitioners of science, scientists themselves, as they do also for organizations engaged in scientific work. We also discussed how cumulative advantage in science directs our attention to the ways in which initial comparative advantages of trained capacity, structural location and available resources make for successive increments of advantage, such that the gaps between the haves and the have-nots in science, as in other domains of social life, widen until dampened by countervailing forces. And in today's lecture, we are going to discuss two things. One is countervailing processes and the other the symbolism of intellectual property in science. Then what is that intellectual property in science? As we have discussed, Merton proposed the seeming paradox that in science private property is established by having its substance freely given to others who might want to make use of it. Okay? And certain institutionalized aspects of this property system, chiefly in the form of public acknowledgement of the source of knowledge and information thus freely bestowed on fellow scientists, relate to the social and cognitive structures of science in interesting ways that affect the collective advancement of scientific knowledge. The Matthew effect in its generality, what we find on the basis of Harriet Zuckerman's hours-long interviews with Nobel laureates in the early 1960s, that eminent scientists get disproportionately great credit for their contributions to science, while relatively unknown ones tend to get disproportionately little for their occasionally comparable contributions. That is what we discussed. The world of science is structured in such a way that more scientists at the bottom are found with a few rewards and recognitions, whereas a very few scientists at the top that which are found with more rewards and recognitions. That is why, for example, if a prize a prize will almost always be awarded to the most senior researcher involved in a project, even if all the work was done by a graduate student or a PhD research scholar or or a junior scientist. Okay? That is why a laureate said, I am just quoting that the world is peculiar in this matter, how it gives credit. It tends to give the credit to already famous people. Okay? The claim that prime recognition for scientific work by informed peers and not merely by the inevitably uninformed lay public is skewed in favor of established scientists requires, of course, that the nature and quality of these diversely appraised contributions be identical or at least much the same. That condition is approximated in cases of full collaboration and in cases of independent multiple discoveries. In the context of independent multiple discoveries, we have discussed the controversies so far as the ownership between Newton and Leibniz are concerned. The distinctive contributions of collaborators are often difficult to disentangle independent multiple discoveries, if not identical, or at least enough alike to be defined as functional equivalents by the principles involved or by their informed peers. It is such patterns of the misallocation of recognition for scientific work that Merton described as the Matthew effect, the not quite foreordained term derives of course from the first book of the New Testament, the Gospel according to Matthew. In the stately prose of the King James Version, created by what must be one of the most scrupulous and consequential teams of scholars in Western history, the well remembered passage reads, "For unto everyone that hath shall be given, and he shall have abundance, but from him that hath not shall be taken away even that which he hath." I mean, for unto everyone that he has shall be given, and he shall have abundance, and from him that has not shall be taken away even that which he has. I mean, such a spiritual account of inequalities in science. Let us try to make a shift from such spiritual account of the inequalities in science to a more secular worldview. Okay? The Matthew effect in its generality is the accruing of large increments of peer recognition to scientists of great repute for particular contributions, in contrast to the minimizing or withholding of such recognition for scientists who have not yet made their mark. The biblical parable generates a corresponding sociological parable. That is why we said let us make a shift from a spiritual account to a more secular account of the inequalities in science. For this is the form, it seems, that the distribution of psychic income and cognitive wealth in science also takes. And how this comes to be and with what consequences for the fate of individual scientists, I mean practitioners of science, and the advancement of scientific knowledge are the questions in hand. Then we have discussed accumulation of advantage and disadvantage among the young scientists, junior scientists, research scholars, graduate students, and so on. Special problems in the accumulation of advantage and disadvantage that derive from an institutionalized bias in favor of precocity, the advantages that come with early accomplishment taken as a sign of things to come, stand in Matthew-like contrast to the situation confronted by young scientists whose work is judged as ordinary. Such early prognostic judgments lead in some unknown fraction of cases to inadvertent suppression of talent through the process of the self-fulfilling prophecy. Furthermore, this is more likely to be the case in a society such as the American society, where educational institutions are so organized as to put a premium on relatively early manifestations of ability in a word, or precocity, on precocity. Okay? The social fact in Durkheimian sense, okay, is of no small consequence for the collective advancement of knowledge as well as for distributive justice. As Gregg argues, precocity thus may succeed in the immediate competitive struggle, but in the long run at the expense of mutants having a slower rate of development but greater potentialities. Okay? And such differential outcomes in the form of slower rate of development but greater potentialities, such differential outcomes need not be intended by the people engaged in running our educational institutions and thereby affecting patterns of social selection. Okay? As we have already discussed, that selection is based on cultural relevance, okay? in the sense of Weberian methodology of social sciences. Okay? And it is such unanticipated and unintended consequences of purposive social action, in this case rewarding primarily early signs of ability that tend to persist. Okay? What is this? There are 2-3 things here. One is unanticipated or unintended consequences of purposive social action. Okay? Purposive social action is alternatively known as goal-oriented social action. There are in Weberian typology of social action, if you look at, okay, there are 4 types of social action. One is traditional social action, 2 affective or emotive social action, 3 value oriented social action, and 4 goal oriented social action or instrumental rationality. Okay. For Weber, traditional social action and affective or emotive social action, they are unreflective in nature, okay, and hence meaningless. For Weber, value rational social action or value oriented social action and goal rational social action or purposive social action or instrumental rationality, they are reflective in nature and hence meaningful. Okay. In this context, we are discussing purposive social action, which is a meaningful social action, which is a reflective social action. In this sense, we are using purposive social action or goal oriented social action. Okay. Unintended or unanticipated consequences, when we talk about, okay, it is very specific to Robert King Merton's coinage of manifest and latent functions, okay, where you find the what are manifest functions? Now, manifest functions are those where you will find there is a coincidence, I mean that there must, I mean both subjective dispositions as well as objective consequences must coincide. Okay. And latent functions are those where you will find that subjective dispositions and objective consequences do not coincide. Okay. In this sense, Merton was using unanticipated, unintended consequences of purposive social action. Purposive social action he has taken from Weber, and in this case rewarding primarily early signs of ability that tend to persist. Okay. For they are latent, not manifest social problems, that is social conditions and processes that are at odds with certain interests and values of the society, but are not generally recognized as being so. What is this? What we were discussing, latent and manifest functions, when I said manifest functions are those where you will find subjective dispositions and objective consequences coincide, and latent functions are those where you will find subjective dispositions and objective consequences do not coincide. Okay. That these I mean the consequences of social action in manifest functions are very much intended, are very much anticipated, whereas in latent functions, okay, consequences of social action are unintended or unanticipated. Okay. That is why social conditions and processes which are at odds with certain interests and values of the society, but are not generally recognized as being so. Okay. In identifying the wastage that results from marked inequalities in the training and exercise of socially prized many talent, social scientists bring into focus that has been experienced by as only a personal problem rather than a social problem requiring new institutional arrangements for its reduction or elimination. In this context, what we find, such inequalities which have arisen from such from the ways in which the world of science has been structured. Okay. It is not simply an individual problem, but a social problem which requires new institutional arrangements to eliminate such inequality. What do we mean by new institutional arrangements? New institutional arrangements may refer to new institutional mandates, rules, regulations, norms, values, interests, meanings, and so on. Okay? And those interests, meanings, values, norms, objectives, goals, rules, regulations, they must be mediated by our economy, our culture, our polity, our state, our society, and so on. Okay? Now, what holds for the accumulation of advantage and of disadvantage in the earliest years of education would hold also at a later stage for those youngsters who have made their way into fields of science, and scholars who not having yet exhibited prime performance are shunted off into the less stimulating milieus for scientific work with their limited resources. Therein lies the source of inequality, the structure of inequality, and science is not an exception to this. Absent or in short supply of absent or in short supply are the resources of access to needed equipment, an abundance of able assistants, time institutionally set aside for research, and above all perhaps a cognitive microenvironment composed of colleagues at the research front who are themselves evokers of excellence, bringing all the best in the people around them. Not least is the special resource of being located at strategic nodes in the networks of scientific communication that provide ready access to information at the frontiers of research. By hypothesis, some unknown fraction of the precocious workers in the vineyards of science are caught up in a process of cumulative disadvantage that removes them early on from the system of stern of scientific work and scholarship. Then the kind of other social and cognitive contexts which may make for such pattern differentials of cumulative advantage and disadvantage we have already discussed. I mean, social and cognitive, the terms social and cognitive cannot be separately examined, they must be examined in relation to each other, okay? Any attempt to treat them separately would be misleading. Okay? And as Zuckerman suggests as an example, that just as class origins may differentially affect the rates at which potential late bloomers remain in the educational system long enough to bloom, so academic disciplines may differ in an unplanned tolerance for late blooming. Disciplines in which scholars often develop comparatively late, say the humanities, presumably provide greater opportunities for late bloomers than those in which early maturation is more common, say mathematics and the physical and biological sciences. Generalized, these conjectures hold that contextual differences such as social class or fields of intellectual activity, as well as individual differences in the pattern of intellectual growth affect the likelihood of success and failure for potential late bloomers. Differences in individual capabilities aside, then processes of accumulative advantage and disadvantage accentuate inequalities in science and learning, inequalities of peer recognition, inequalities of access to resources, and inequalities of scientific productivity. Individual self-selection and institutional social selection interact to affect successive probabilities of being variously located in the opportunity structure of science. Okay? This is very important. When we select, it is as it is based on cultural relevance for Weber, okay? And we discuss inequalities of peer recognition, inequalities of access to resources, inequalities of scientific productivity, okay? And more importantly, when you talk about democracy, freedom to dissent is very much integral to the idea of democracy. Such inequalities in the context of freedom to dissent, okay, is such inequalities in the context of freedom to dissent must be examined at length and in detail. Okay? When we talk about the process of democratization, we talk about there must be free accessibility to scientific knowledge, democratization in the context of scientific knowledge we are discussing here, not democratization per se. Okay? Whenever we talk about the process of democratization, we talk about the process of democratization in the context of democratization of science, in the context of accessibility to scientific knowledge, equality of opportunities to do science, to practice science. But more importantly, we must look at the aspect of freedom to dissent, which is integral to the idea of democracy itself. Okay? Such inequalities in exercising one's freedom to dissent must be integral to the idea of science itself. Okay? That is how science should be made more democratic. Okay? And when we talk about individual self-selection and institutional self-selection, there we talk about, there we can go back to new institutional arrangements. Okay? When we talk about new institutional arrangements, okay, our work, our selection, it is also determined by the institutional mandates, new institutional arrangements, norms, values, rules, regulations, institutional framework as such. Okay? That is why I do not carry out study, okay, just as a curiosity driven research, but also as a part of contract obligations. That is where the aspect of intellectual property lies in. If you look at the way scientific knowledge, the way science has been pursued, practiced, okay, scientific research has been conducted, okay, it has made a shift from being a curiosity driven research to a level where it can be considered a part of contract obligations. Okay? That is why individual self-selection and institutional social selection must interact to affect successive probabilities of being variously located in the opportunity structure of science. When the scientific role performance of individuals measures up to or conspicuously exceeds the standards of a particular institution or discipline, whether this be a matter of ability or of chance, there begins a process of cumulative advantage in which those individuals tend to acquire successively enlarged opportunities for advancing their work and the rewards that go with it even further. Okay? Since top-notch institutions, elite institutions have comparatively large resources for advancing research in certain domains, talent that finds its way into these institutions early has the enlarged potential of acquiring differentially accumulating advantages, and the systems of reward, allocation of resources and other elements of social selection thus operate to create and to maintain a class structure in science by providing a stratified distribution of chances among scientists for significant scientific work. What we have been doing, we have been using this term class. Okay? Merton here was using both Marxist tradition as well as American tradition, Weberian tradition. Though Weber was from Germany, but his views on social structure, his views on class, his views on status, his views on party, his views on different social problems, okay, they are very much, they are in general they are assigned to the American tradition. Okay. In this sense, Merton was using both the traditions. For Marx, classes are the manifestations of economic differentiation. Classes are, for Marx again, classes are constituted not on the basis of income, but on the basis of the position one occupies or the functions one performs in the process of production. For example, there are two blacksmiths, one the owner and the other a paid worker, both belong to two different classes, not one. Okay? Marx was not the first to discover social classes or their plights. Many philosophers did it before him. But Marx came to the center stage when he said the philosophers have only interpreted the world in various ways. The point, however, is to change it. It does not imply that he was not attributing any significance to interpretation, but for him, not simply interpretation, but the desirability to secure changes, to have changes assumes greater significance, is more important. Okay? Then what is class for Weber? For Weber, classes are determined or based on the kind of life chances and causal components that we have. Okay? And Merton was influenced by both these traditions, both these thought processes, okay, in terms of manifestations of economic differentiation as proposed by Marx, as well as in terms of life chances and causal components as proposed by Max Weber. Okay. And when we look at this, the systems of reward, allocation of resources and other elements of social selection by institutional social selection, not individual self selection, but institutional social selection. It is always, it is often determined by the kind of structure that you have. Okay? That is why on a different note, let me put it this way. Once Marx said, men make their own history, but they do not make it under self-selected circumstances. Okay? But the most important part which must be noted here, that the tradition of all dead generations weighs like a nightmare on the brains of the living. That is what Marx said. Whatever action that individual undertakes, okay, is guided by some institutional framework, is guided by some structure, is guided by some framework which is historically conditioned. Okay? And even today, there is no second opinion about it. Okay? Or there is any hardly second opinion. Okay? Then we have discussed accumulation of advantage and disadvantage among scientific institutions. The kind of skewed distributions of resources and productivity that resemble those who we have noted among individual scientists are found among scientific institutions. Okay? What we have been doing? We have already discussed accumulation of advantage and disadvantage among scientists, then accumulation of advantage and disadvantage among the young scientists, research scholars, graduate students, junior scientists and so on, and now we are discussing accumulation of advantage and disadvantage among scientific institutions, research organizations and so on. And the kind of skewed distributions of resources and productivity that we find among scientific institutions that resemble those who we have noted among individual scientists are found among scientific institutions. And these inequalities also appear to result from self-augmenting processes. Clearly, the centers of historically demonstrated accomplishments in science attract far larger resources of every kind, human and material resources, than research organizations that have not yet made their mark. Okay? Now, the central question where we stopped in the last lecture, that if the processes of accumulating advantage and disadvantage are truly at work, why are there not even greater inequalities that have been found to obtain? Okay? From here, we are going to discuss two important components in today's lecture, about countervailing processes as well as the symbolism of intellectual property in science. Okay. What are these countervailing processes? Okay. Put it, let me put this more generally. Okay. Why do the posited processes of accumulating advantage and disadvantage not continue without assignable limit? When two systems grow at different exponential rates, okay, the gap between them swiftly and greatly widens. Yet, we sometimes forget that as such a gap approaches a limit, other forces come into play to constrain still further considerations and inequalities of whatever matters are in question. Okay. Such countervailing processes that close off the endless accumulation of advantage have not yet been systematically investigated for the case of science, more particularly for the distribution of human and material resources in research universities and of scientific productivity within them. Let us discuss this in detail. Okay. As Merton tried to refer to Derek D. J. Solar Price, who was fond of saying in this connection, if the exponential rate of growth in the number of scientists during the past in the first half of the 20th century were simply extrapolated, then every man, woman and child, to say nothing of their cats and dogs, would have to end up as scientists, yet we have an intuitive sense that somehow they will not. In much the same way, every school going child knows that when two systems grow at differing exponential rates, that is what the gap between between them swiftly and greatly widens. Yet we sometimes forget that as such a gap approaches a limit, other forces come into play to constrain still further concentrations and inequalities of whatever matters are in question. And such countervailing processes that close off the endless accumulation of advantage have not yet been systematically investigated for the case of science, more particularly for the distribution of two types of resources, both human as well as material resources in research universities and of scientific productivity within them. Okay? Any university to grow, you need both human and material resources. Okay? Still, Merton tried to speculate briefly about the forms of countervailing processes which might take. Okay? Merton suggested that let us consider, for example, the notion of an excessive density of talent. It is not a frivolous question to ask. How much concentrated talent can a single academic department or research unit actually stand? How many prime movers in a particular research area can work effectively in a single place? Perhaps there really can be too much of an abstractly good thing. Okay? Think a bit about the patterned motivations of oncoming talents as they confront a high density of talented masters in the same department or research unit. Okay? The more autonomous among them might not entirely enjoy the prospect of remaining in the vicinity and with the Matthew effect at work in the shadow of their masters, especially if they felt, as youth understandably often comes to feel, sometimes with ample grounds, that those masters have seen their best stage. Correlatively, some of the firmly established masters in a pattern of master apprentice ambivalence may not release the thought of having exceedingly talented younger associates in their own or competing research terrains, who they perceive might subject them to premature replacement, at least in local peer esteem, when, as anyone can see, the masters are still in their undoubted prime. Not every one of us elders has the same powers as critical self-appraisal and the same largeness of spirit. Okay? What Merton tried to mean that at least during the years of seemingly limitless academic influence and expansion, a person like I mean a mathematician like Isaac Barrow, okay, would have stayed on and Newton would have been given a new chair. But again, as we have ample cause to so know, continued expansion of that kind in any one institution also has its limits. Apart from forces generated within universities that make for dispersion of human capital in science and learning, there is also the systemic process of social and cognitive competition among universities. Entering into that external competition is the fact that the total resources available to a university or research institute must be allocated somehow amongst its constituent units. Some departments works poor even in rich universities, I mean in elite institutions. This provides opportunities to institutions of considerably smaller resources and reputation. What Merton meant here, that apart from forces which are generated within universities, what are those forces? I mean human and material resources. Okay? There is, apart from these human and material resources, there is within universities, there is also the systemic process of social and cognitive competition among universities. Okay? And such external competition is the fact that the total resources available to a university or research institute must be allocated somehow amongst its constituent units. You may find that some departments perform poor even in rich universities, and some departments in poor universities, in weak universities, you will also find I mean some departments perform very well even in weak universities. And when some departments perform poor even in rich universities, such situation provides opportunities to institutions of considerably smaller resources of reputation. And these may elect to concentrate their limited resources in in specific fields and departments, and so to provide competitively attractive microenvironments to talents of their first class in those fields. As another countervailing process, okay, populist and democratic values may be called into play in the wider society, in the wider social arena, external to academic institutions and to science, and lead governmental largesse to be more widely spread in a calculated effort to counteract accumulating advantage in the great centers of learning and research. Okay? But apart from such speculations, what Merton did, Merton tried not to defer the examination of the symbolism of intellectual property in science by continuing with observations on countervailing forces, countervailing processes, okay, that emerge to curb the accumulation of advantage that might otherwise lead to a permanent institutional monopoly or sustained oligopoly in fields of science, and the sustained domination of a few individuals in those fields. Just as there is reason to know that the preeminence of individual scientists will inexorably come to an end, so there is reason to expect that various preeminent departments of science will decline while others rise in the fullness of time. Then such countervailing forces that we have discussed, okay, from here onward, okay, will move on to the symbolism of intellectual property in science. Okay. There must have some way of thinking about about the distinctive equivalence in the domain of science of income and property found in the economic domain. How do scientists manage to perceive one another simultaneously as peers and as unequals, in the sense of some being first among equals? What is the distinctive nature of intellectual property in science? To explore the forms of inequality in science, okay, registered by such concepts as the Matthew effect and the accumulation of advantage, we must have some way of thinking about the distinctive equivalence, okay, in the domain of science of income, okay, and property and wealth found in the economic domain. Okay. That is why Merton tried to pose such questions that how do scientists manage to perceive one another simultaneously as peers and as unequals, in the sense of some being first among the equals? What is the distinctive nature of intellectual property in science? I mean, the tentative answer to the coinage question, which Merton proposed way back in 1957, seems to have gained force in the light of subsequent work within the sociology of science. The system of coinage is taken to be based on the public recognition of one's scientific contributions by qualified peers. That coinage comes in various denominations. Largest in scale and shortest in supply is the towering recognition symbolized by eponyms for an entire epoch in science, as when we speak Newtonian, Darwinian, Freudian, Einsteinian, or even Keynesian eras. Okay. A considerable plane below, though still close to a summit recognition in our time, is the Nobel Prize. Okay. Other forms and echelons of eponymy, the practice of affixing the names of scientists to all or part of what they have contributed, comprise thousands of eponymous laws, theories, theorems, hypotheses and constants, as when we speak of Gauss's theorems, Planck's constant, the Heisenberg uncertainty principle, a Pareto distribution, a Gini coefficient, or a Lagersfeld latent structure. Other forms of peer recognition distributed to far larger numbers take further graded forms: election to honorific scientific societies, medals and awards of various kinds, named chairs in institutions of learning and research, and moving to what is surely the most widespread and altogether basic form of scholarly recognition, I mean, that which comes with having one's work used and explicitly acknowledged by one's peers. Okay. I mean, the way Merton tried to argue here that cognitive wealth in science is the changing stock of knowledge, while the socially based psychic income of scientists takes the form of pellets of peer recognition that aggregate into reputational wealth. Okay? This is very important. Okay?